Good evening, everyone. I welcome you all in this workshop of Quantum AI. It is indeed a pleasure to see you all joining us this evening. And I hope many of you are students, many of you must be faculties, and you also must be machine learning, artificial intelligence enthusiasts, having a keen interest into what probably the future technology is. We also have registrations and participation from many corporate professionals. So it is indeed a pleasure to have you all here. I would also request all of you to kindly inform and share with your fellow friends who registered along with you, because many a times your message could help them to join in, and it will also encourage us to have a good number of participation and to share this knowledge with you all. So very soon we will begin. I can see people are joining in, and meanwhile, let all other people join. I would really like to ask you, if you are a student, you can write student. Along with it, you can write whatever graduation, post-graduation you are doing. If you are a faculty or a trainer, you can write that you are a faculty, just write faculty. And along with that, you can write your specialization. If you are a working professional, so you can simply write working, and again your area of expertise, or you can write about whatever technology you are working on. That will help and encourage all other members also to understand that who all are the participants of this particular workshop. And I'm also trying to see here that what all different domains you are having, so that accordingly, when we are exploring the things, we can understand that what kind of expertise, what kind of different from different walks of life, different professional domains, functional areas of industry, people are connected. Thanks a lot, Prabhakar, Ronak, Rishi, Yogesh, for sharing what exactly you are doing. So now I think it is high time we should start this particular event. This event is a bit different from the past events which we have been conducting. And this is different in a sense that last event, or the continuously we are conducting many events, we are conducting them only for a single day. But this particular event we are conducting in different way. We will have one session today, and we will have more upcoming sessions. Few sessions will be similar way on YouTube Live. Few sessions we will offer as one-to-one on Zoom. And I would very happily tell you that we are also launching some of our courses related to business intelligence, Power BI on Udemy as well. So we may have certain sessions there also. So this would be a little different and very interesting, because quantum, the term itself is something which everyone tries to go through and understand. So let us now start. Let's have the next slide, And we will have certain pointers in the next slide, which will help us to understand that what all are we going to cover throughout these interactions, throughout the interactions, and through some demonstrations, exploring some platforms, exploring concepts. Certain concepts are very old, certain concepts are very much new, and which are being talked about. So, all these things we will be exploring and we'll be working upon. Thanks a lot, everyone, for sharing your areas of expertise, your domains. And now let me start. Okay, so the agenda is in front of you. Before we enter into quantum mechanics, we need to understand the whole scenario of the old physics and the new physics. Old physics, where we have theories from Newton, and we talk about Einstein. And when we talk about Einstein and the kind of work he has done, like theory of relativity, in this particular context, we say that it is the beginning of new physics. Old physics can be termed as classical one, and the new physics can be termed as quantum physics. When I say quantum physics, or when I say quantum mechanics, you can take them synonymous. Like quantum physics and quantum mechanics, you can take, they are the same thing. They're not different things. So quantum AI is something we need to understand and explore. But before entering into this particular domain, we also need to understand that what exactly is old physics, what kind of thought process or understanding we had in old physics, that is the classical one, and what understanding we got with the development and understanding and discovery and experimentation of quantum or the new physics. So, this is the first part which we will be discussing and understanding. And after that, we will enter into what exactly is quantum computing. And then we will move on to machine learning and what is quantum machine learning. The algorithms of machine learning, if we see in the realm of quantum, then how the quantum algorithms would work. Still, we have a lot of errors in case of quantum algorithms. And when we have errors, when we have faulty behavior, then we need to understand the optimization, how we can optimize the quantum algorithms. We also will understand the concept of entanglement, superposition, annealing, and error correction. By understanding all these concepts, we will also look upon the applications, how quantum AI is going to get applied, and that is going to help us to give us a direction of how the future is going to be with quantum computing, quantum AI. So, this is the whole agenda of the workshop. If you have any kind of queries or questions, please feel very much free to write us on the comment box. Because as I am promising you, this workshop is a bit different, and this workshop is going to be continued, and we will have further sessions also. Many of you have a query that whether we will get certificates or not. So let me help everyone that yes, all our workshops have got certification and certificate of participation. We also have some special certificates with those candidates who share us photographs of themselves. It may be a selfie that you are attending this workshop. It may be whenever we have practical sessions. So it will be practical session. You take a screenshot and a photograph of the practical session you are attending. So whenever you are attending, you can share such things with our team. And from wherever, whichever mail you got the email, you can share on the email, or you can share on the number from whichever number you got the message of joining this particular workshop. And that is going to help us also encourage that yes, you are gaining something out of these events. Let us have the next slide and let us start with the first topic. And the first topic is understanding the prerequisites. So I'm continuously watching your comments also. Yes, I'm continuously watching the comments also. So if you have any kind of questions or queries, you can surely put them in the comment box. So I will request my team to let's have the next slide. And we will begin with the prerequisites part. The prerequisite is all about the old physics and the new physics. So many of you might be thinking that we are from technology background, we are from IT background. So why basically we have physics here? And before we will move ahead, so normally I try to prevent using these kind of words, but I got this word from one of the very renowned speaker. So that renowned speaker said that he normally doesn't take up any kind of comments or any kind of live discussions. And he told the reason. He said that a lot of online cockroaches visit and they keep on spoiling the whole comment box. So I normally avoid these kind of words. But when I was listening to him, it was quite funny. But it was the same experience with us also in the previous live sessions. We got a cockroach and he spoiled the whole chat. So we have our team to manage and moderate the comments here. Thanks to my team taking some extra efforts for doing this. So yes, so as I was explaining and I started to explain about the old physics and the new physics, very interesting. How it is very interesting, let me tell you. The old physics, the notion, if you see, specifically about how the whole world, how this universe is constructed or created or built up of. So old physics says that the whole of the whole of the world is created out of some fundamental particles. And if you see that the fundamental particles we have, the fundamental particles. So fundamental particles are constructed of basic building blocks. And what are these basic building blocks? These basic building blocks are atoms. I would here right away ask a question. What do you think? What is your understanding? What are the fundamental building blocks of this whole universe or whatever item you see? Let's say the item could be as simple as I have this visiting card. So let's say this visiting card is there. Okay, I'm showing this visiting card. So what do you think? What are these visiting cards made up of? Tell me in the comment box. So the old physics says that the building blocks are atoms. So I'm asking your understanding. What is your understanding? What do you think? What are these building blocks made up of? Are these atoms or something else? What are these building blocks? So understand, like scientists or researchers, it is their basically, statement. They researched and they were able to identify that atoms are the building blocks. Okay, atoms are the building blocks. But once we developed our understanding, we got to update that atoms are not the building blocks. What is the understanding? That this is one atom, this is another atom, and these two atoms come together and create a chemical compound. Multiple chemical compounds, they come together, and these multiple chemical compounds, they form a object. Like I have shown you this particular card. So this card is made up with different atoms. Okay. But new physics says something else. So I'll request the team, whenever I'll talk about old physics, you can have the slide of old physics. And whenever I talk about the new physics, you can just click on next and we can have the new physics text. Okay. So the new physics says that we can break these atoms into smaller particles. And these smaller particles are electrons, protons, and neutrons. So this is what we have also studied in our school time also. So electron, proton, and neutron, these are basically the concept of new physics. So when we have electron, when we have proton, when we have neutron, we got to know that neutron is at the center, and along with it, protons are available, and electrons are revolving. They're dancing around the neutron. So they're dancing. And whenever there is a gap in the balance, there is a balance of neutrons and neutrons and electrons. If this gap, if you see that, if this gap is getting created, then electrons, they create a valence. And this valency, if you see, it basically attracts some other electron from some other atom. So you can see that here we have one atom which is having, let's say, one electron less. Okay. So here if you see, we have one atom, it is having one requirement for electron. And we have one atom here, it is having one extra electron. Okay, so I'll repeat. So we have one atom, and this atom is made up of electrons, protons, and neutrons. And at the beginning, if you see, at the beginning, we have this particular atom having one electron lesser. And we have the other atom, and this particular atom is having one electron additional. So this is unstable. This one is also unstable. Both are unstable. So if both of them are unstable, what is happening here? What is happening? Now they will react. And when they will react, so in this particular reaction, they will create a compound. Okay, so two atoms will create a compound. The electron of this particular atom is now fulfilling the gap in the first atom, and both of them have combined, and now two atoms have created one compound. This is what new physics says, but this was not understood in the old physics. So this is the difference, and this difference we were able to understand when new physics came into existence. Okay. Now, what about concept of time? If you see the concept of time in the old physics, in the old physics, time was independent. Independent means what? Like now, time is flowing. We should go back to the slide of old physics. Yeah. So if you see in the old physics, the concept of time is that it is basically flowing irrespective of any other event. Let's say, now observe my hand. My hand is here. Okay. Now I moved my hand from here to this particular place. So whether my hand moved to this particular place, it has nothing to do with the time. So time is something which is independent. Okay, independent. It has nothing to do with anything, any existence. But when we talk about time with respect to new physics, time is a relative concept. How? Let's say, if you want to tell me that my hand was here and now my hand is here, how would you be able to tell me this thing? Like, my hand is here, now my hand is here. So if you want to explain the positions of my hand, how would you explain? Okay, let's say this is position 1, this is position 2, this is position 3. How would you explain? In new physics, now let's understand the concept of time. So at time t1, my hand is at position p1. At time t2, my hand is at position t2, p2. And at time t3, my hand is at position p3. So understand what is happening. Time is relative. So with the help of time, I am able to explain my hand's position p1, p2, and p3. Otherwise, if I just say p1, p2, p3, what does it mean? It just shows 3 positions, but it doesn't tell us that what when the hand was at p1, when the hand was at p2, and when the hand was at p3. With respect to time, we can tell this thing. So this is again very interesting, new physics. So at one point, we are talking about that how old physics was looking at everything at macro level. Macro, like these eyes see things at macro level. Even I'm wearing the specs. With the help of specs also, I'm able to see things at macro level. But the new physics, if you see, new physics came with the notion of micro level. Okay, micro level things. Let me tell you certain more things. Now, let's say we have a particle. We call it as matter. What is particle? Particle is a matter only, right? So we have particle, and particle is matter. Okay. Now, if we have a particle and we have a boundary like this, okay, assume that this is the boundary, and I want a particle from here to get transmitted through this boundary. Old physics says it is not possible. Old physics says we have a particle, this is a boundary, this boundary is again made up of particle, and the particle is traveling and is trying to pass through this particular boundary. So particle would not be able to pass through this because it will hit this boundary and it will remain here only. Old physics concept. Okay, about matter and the particles. So particles have got an existence, a physical existence, and this particular physical existence basically tells us that the particle cannot move through this particular wall, this boundary. But new physics, it comes up with a concept, and there is a concept of particle wave duality. There's a concept of particle wave duality, which means that a particle can act as a particle also, and the particle can also act as a wave. When a particle is acting as a wave, it can transmit, it can get transmitted through this physical wall or physical boundary as well. Again, the new physics breaks the notion of old physics. So new physics says that particle can have dual nature. When there is a dual nature, when it is depicting nature of a wave, it will pass through this particular card as well. This is what is called as wave particle duality. And this is possible. Experimentally, we have seen this. Now, can you understand that we have a particle which is having physical existence, and we have a wave. We have a wave which is having non-physical existence. And a particle is showing both the nature, matter is showing both the nature. So old physics termed this as that particles are distinct, waves are distinct, and they are not same. But new physics says that the particle and waves, they are dual behavior of the same thing. Like we have electrons, they behave like a particle also, and they behave like a wave also. Okay, so let's move ahead and try to understand the last concept in the old and new physics. We can have this quantum computing slide, no problem. So now let us understand this particular concept. So we have particles, an atom is there. If you break the atom is going to get divided into protons, neutrons, electrons. Can you further divide them? Is it possible? Can you tell me? Can we further divide it? An atom is there. Can we further divide this atom into electron, proton? Yes. So can we further divide electrons, protons, and neutrons? What do you think? What do you say? What do you say? Okay. The answer is yes. The answer is yes, we can divide. We have smaller particles. We have neutrinos. Okay, yes, we have neutrinos. We have further particles. And further particles are, yes, very good, Amzil. We have quarks. Very small particles, further divided. Understand? So even the smallest unit, which was considered to be smallest unit, can be divided into electron, proton, and neutron. And these can also be, very good, yes, hadrons, baryons, quarks. And you know, when we divide these quarks, when we try to further divide them, so as per our current understanding, we see that they burst into energy. They lose their physical existence. They lose their physical existence. Understand what we are talking about. Just try to imagine whatever you are seeing around, all of that is built up of as per the classical old physics. All of you are seeing around the fan, the light, the mobile phones, the laptops, all of the things you are seeing around, all of these things are made up as per the old physics of atoms. And it is true, they are made up of atoms. New physics tells us, the quantum physics, quantum mechanics tells us that these atoms are made up of electron, proton, and neutron. So just imagine, try to do this exercise with me. Everything, just imagine the atoms. You are able to, disintegrate, dismantle everything. And you're able to see that, okay, atoms are there. So the fan is now dismantled and atoms are floating in front of you. Just imagine. So your atoms are floating. And when you are dividing, you can see that your nucleus is there, neutrons are there, protons are there, electrons are there. You can see them. Let's say you're able to see them. They're all dancing. And now, when all of them are dancing here, what is further happening? Further, you are trying to break them. You are getting some neutrinos, quarks, or hadrons, or baryons. You are getting these kind of smaller entities. And further, all these entities are in front of you. You're further trying to break them down. And they all got burst into energy. Are they having any physical existence now? Can you imagine where that fan has gone? That fan has got transformed completely into energy. It may be heat energy, it may be sound energy. The fan, a physical entity, has got completely transformed into what? Into energy. And therefore, we say that energy can neither be created nor be destroyed, but can be transformed from one form to another form. And we must know that the forms could be physical and non-physical too. The forms could be matter and non-matter too. This is what we should understand. And here we are able to understand the quantum nature. The quantum nature. So till now, I have been using the word old physics, new physics. The old physics is termed as classical physics, and the new physics is termed as quantum physics or quantum mechanics. If you all are on the same page, if you all have understood so far, please do write same page or SP in the comment box. That will help me to understand that yes, we all are on the same page and we have understood what we were discussing. And then we will be moving towards the concept quantum computing, which is in front of you. All right. So great. Thanks a lot. Thanks a lot, everyone, for giving quick feedbacks. Yes. So now very interesting, further interesting things. So quantum computing, it comes from quantum mechanics. The inspiration, the idea comes from quantum mechanics. So quantum mechanics and quantum physics, take them synonymous as of now. Take them as same thing as of now. So it comes from the area which describes the behavior of matter and energy at atomic and subatomic level. This is what we have been discussing so far. So matter and energy at atomic and subatomic level. This is quantum mechanics. And quantum computing takes or leverages the principles of quantum mechanics so that we can build quantum computers. We have concepts like bits, in classical computers. We have concept like quantum bits in case of quantum computers. So at one place we have bits, and at the other place we have quantum bits. So let us try to understand that how this quantum computing concept is evolved, and what are the constituents or constructing material of quantum computing. Let's have the next slide and try to understand about bits, qubits, superposition, and entanglement. Now, I hope all of us are very much aware about bits. What is the language of computer? Our computer understands zeros and ones. So binary is the language of our computer. Now, bits basically represent 0 and 1. So 0 is one state and 1 is another state. But in case of quantum computing, we don't go with 0 and 1. These are called as classical bits, 0 and 1. So what a lot of problems can be solved with the help of zeros and ones. Let's say disease or no disease. Let's say legitimate and let's say some non-legitimate. Let's say day and night, yes and no. So you can see that a lot of binary problems can be solved with the help of bits, the concept of bits. Now, qubits behave little differently. This is little odd. How this is odd? Can we say that I'm talking to you and at the same time I'm silent? Can we say like this? Can we say that it is day and at the same time can we say it is night? Can we say that it is good and at the same time can we say it is bad? Can we say the cat is alive? At the same time, can we say the cat is dead? Tell me in the comment box. Can we say? Tell me in the comment box. Can we say like this? Can I say I'm live? At the same time, I'm dead. I'm here sitting I'm here sitting. At the same time, can I say I'm standing? Can I say like this? Can I say like this? So I got one response, theoretically, yes. Can you think of that at this particular moment, I'm present here. At this particular moment, I'm sitting next to you. At this particular moment, I'm having this discussion with you. And at this particular moment, I'm also watching a movie. Or probably more than this. At this particular moment, I'm sitting. At this particular moment, I'm standing. At this particular moment, I'm walking. At this particular moment, I'm dancing. At this particular moment, I'm flying. But you are able to see me, I'm sitting over here because you are seeing me like this. You are able to see me that I'm sitting over here and interacting with you because your eyes want to see me like this. So the concept is that the quantum physics says, so not many answers I'm getting as yes, no, yes, no. Okay, wow, Schrodinger cat. Wonderful, wonderful input. Quantum mechanics says that it is possible. It is possible that things, things, but we are able to see them, that we are able to see them. So a particular thing at a particular moment can have multiple states, multiple states. But as soon as observer comes into picture, remember, as soon as observer comes into picture, that particular things takes a particular shape, enters into a particular state, and that particular thing shows itself to you because you are the observer. A little odd example I'll give you. Odd in the sense, I'll give you example from theory of relativity. Okay, from theory of relativity I'll give you example. Okay, later on we will have more examples because this is very interesting subject and even I really like it. Okay, so I hope you will enjoy further sessions more. So now I hope when you were a kid you all must have had this particular experiment done. Put the fan on, put the fan on, and let the fan start rotating. Till this particular moment, for you, the fan was at a static position. It was not rotating, it was not moving, it was at static position till this particular point of time. Am I correct? You can respond back in the chat. But as soon as you put the fan on, it starts rotating. You as an observer are observing and the wings are rotating. It's rotating. So the state of the fan has got changed. Now you stand just below the fan and you also start rotating along with the fan. You also start rotating along with the fan. What will you observe? Tell me. What will you observe? If you start rotating along with the fan with the exact same speed, the speed which fan is rotating at, what do you think? Will you be able to see the fan again in a static position or not? Exactly. The fan will appear to be at rest. But your brother is sitting on a chair. For you, the fan appears to be at rest. Your brother is sitting on a chair. For your brother, the fan is still rotating. This example is better explanation of understanding superposition. What we are discussing is superposition. An object can exist in more than one state at a time. An object can exist in more than one state at a time. It depends on the observer. As soon as the observer is observing that particular object, the object enters into a particular state and the observer is seeing that particular thing in that particular state. You know, Einstein was not in favor of quantum physics, quantum mechanics. He was opposing it. He was opposing it. Okay. So when he was opposing it, At that particular moment, at that particular time, what was happening? He said, like, he was like, are you a fool? Like, if you see moon, then only moon exists. If you doesn't see moon, moon doesn't exist. Is it like this? It is his statement. Only if you see the moon exists. And if you don't see the moon, moon doesn't exist. So this is how he was explaining. He was not favoring. Okay, he was not favoring quantum mechanics, quantum physics. So, okay, one question to you before we move ahead. In 2022, who were the scientists who got the Nobel Prize, and at the same time, they proved Einstein's theories wrong? A quick question to you. In the year 2022, who were the researchers, scientists who got the Nobel Prize and they proved the theories of Einstein false? So you can answer this. You might have one question, like Einstein, one of the greatest researcher, scientist of the time. How can we prove the theories of Einstein wrong? Einstein also got Nobel Prize. How can someone get Nobel Prize for someone who also got the Nobel Prize and also for rejecting his work? So this is called as embracing each other's discoveries. This is embracing each other's discoveries. Science is not competition. Science is investigation, researching, experimenting, and finding out new insights. Science is all about that. So embracing what previously is being done and taking motivation from it and trying to observe what further can be done. So the contribution of these researchers is a tribute to the research which was done by Einstein, the theories given by him. Because he gave, that's why we are able to think further. Now let us move ahead and try to understand another funny concept, and it is entanglement. Let's take it in a more funny way. First funny way. How many of you have girlfriends? Or to the girls, how many of you have boyfriends? Okay, only you can share only if you are able to share publicly. Okay, you can share only if you are able to share publicly. If yes, if you have, let's say if you don't have, I'll give you another option. Okay, you may have best friend, Zigri, best study buddies, right? Best friend. So if you are having, okay, get mingled. Okay, Amjad, you can get mingled once once you, whatever aims you have, you achieve, then get mingled in right time. Okay, I'm not here to give such advice, just kidding. So let's say you have very close friend. Have you ever observed that your friend is in risk and you're getting sensations? Or if you love someone and that loved one is in trouble and you are getting some vibes, some feelings. The best example is mother and the child. If there is any kind of issues to the child, some or the other way, the mother gets to know. Mother calls, what happened? Is everything okay? So the kind of relationship we have. Why I'm giving these examples, you can at least write yes or no. Have you experienced such things? Or these are just fancy things to be written in stories and movies? Or are these real? So I'll say, as a human being, I have experienced, okay, I have experienced, it may be a coincidence or it may be something in real, but I feel that yes, there are vibes. Scientifically also vibes are there and we transmit vibes. and the vibes can be touched and can be experienced and felt by other human beings also. This is scientifically proved. We have vibes, we have auras, and we transmit that. Okay. And the frequencies can be experienced by the one who matches up with that frequency. Everyone cannot experience it. So if you are tensed, your vibes can be experienced by your mother. Probably people in the crowd may not be able to experience your vibe. Sometimes it happens that some wise man, he's able to experience. This happens. Okay. So entanglement is something like that. So these vibes, if we try to convert them into logic, these vibes somehow try to make some sort of connection between two people. So entanglement is something like this. I'll explain you. Let's say we have some object here and we have some object here, and there's some sort of connection between these two objects. Okay, some sort of connection between these two objects. So this particular object state is related to this particular object state. Can you recall that movie? Salman Khan, I think Judwa. I don't remember the names of the movies. So if you see that, one is Bhola Bala. Bhola Bala means very naive, very, uh, a kind of very kind-hearted, soft-hearted, unaware of the worldly things. So one character is like that. And another is like Gunda Mawali. Okay. He's like a don. So when they realize, initially they don't realize, this Bhola Bhala guy, this innocent guy, whenever somebody beats this innocent guy, the other guy also gets the slap, gets those punches. But when they realize that they have some connection between them, and the change in the state of the one person is also changing the state of the other person, then basically this innocent one, somebody hits him, then the other one, the Don one, he will just do the action of fighting. The innocent one will also be able to fight. Do you remember this movie? Right? So entanglement is that kind of a concept. One object has got some connection with the other object, and the state of the one object is driven by the state of the other object. Now these two objects are very much nearer to each other. Now no matter how far these two objects are, no matter, but they still will be entangled. They still will have that connection established. The change in the first may lead to change in the other. The one will affect the other. This is called as entanglement. Okay, those who are listening these concepts the first time, the superposition, the entanglement. So qubits basically have a behavior of superposition. Qubits have behavior of entanglement. They show such behavior. So those who are listening for the first time, are you getting a feeling like we are reading some science fiction or we are discussing some science fiction? Are you basically thinking something like that? But this is true. This is quantum computing. This is quantum computing. Okay. So these are the fundamental building blocks: qubits, superposition, and entanglement, which makes it different from the classical computing. So I'll summarize. So classical computing, if you see, it is dealing with very limited, known problems and challenges. Quantum computing is opening up a new option with us, where we can have multiple solutions created at the same time. So that is the doors which are getting opened by quantum computing. So now it is almost 7. I will invite questions from you. You can write the questions. We have already shown the agenda to you, that what exactly are we going to cover in this particular workshop. We have uploaded the whole agenda in the website also. So we have a value system which says that deliver beyond promise. So I promise you that we will deliver beyond what we have written over there, bringing up all the, we will also bring some of the religious and spiritual concepts which are being talked about. We'll also try to discuss all the experiments which are being done and what were the outcomes of those experiments, so that our understanding is very much profound. We'll also do practice with the help of practical labs. So all these things we'll be doing. And for today, I will leave you with this particular homework, that you have to come up with questions, queries, so that it becomes your session. We have our outline, but in order to make it your session, we'll try to go through each and every comment, and we'll come back with that particular content, theoretically, conceptually, and practically as well. So I believe this much is good enough for today, and you can quickly give the feedback in the comment box itself. And yes, Arnav is asking, sir, can you please explain the example of brother and fan again? So Arnav, we will ensure that this recording is available for you so that you can go back, because I explained it in a great length. You can go back and have a look at it. If you still there's a doubt, you can please write back and we'll solve. Okay. Could you please repeat the qubits? Yes, I'll tell you. So I told you about the bits. So bits are basically, in classical computing, 0 and 1. They only represent two states, that is 0 and 1. Qubits are quantum bits. So bits can either be 0 or 1 at a particular moment, at a particular time. But qubit have got different behavior, which comes from the superposition and entanglement. So qubit can represent both at the same time. Qubit represents 0 as well as 1 at the same time. So this is the difference between a classical bit and the quantum bit, that is qubit. So it has the ability to represent both 0 and 1 at the same time. So therefore it is different from the classical computing, the bits concept in the classical computing. I hope it is clear. All right. So thanks a lot for taking out time in the evening and watching this. Please do share this with your friends. We'll still be open up with those who would like to undergo this particular workshop. This workshop would be of around 5 or 6 hours in total, 5 or 6 hours. So we have a lot of exciting things yet to be explored. This is just a trailer. Okay, this is just a trailer, and we will basically keep on updating you. Those who have registered, you'll directly get a message, and we'll share our Google Classroom also, so that we can have an easy basically way of communication here. So for today, we will be concluding here. Once again, thanks a lot, And yes, in the next session, we'll have blue spheres also. We'll discuss them as well. Thank you very much, everyone, for joining in. Thank you very much, students. Thank you very much, colleges and faculties. Thank you very much, MIT World Peace University, who collaborated with us for this particular event. Thank you very much, all the corporate professionals as well, who basically came here and encouraged us. I request my team, I give you a lot of thanks to my team as well. And let's conclude here. We'll see you in the upcoming session. Thank you. Thanks a lot. Have a good day.